This is our video on multiple logistic regression. So first off, we're going to set up in a similar way to the previous video. You'll load dplyr, rocker, ggplot2, caret, and coreplot, and we're going to set the seed again to 1 so you can have the same results that I do. So first off, again, we're going to make the levels of plants into just 2 instead of 3 because iris comes with 3 different levels. And here is what the beginning of our data looks like. So since it's just the first 6 entries, the first 6 species are going to be zeros, but as you go farther down, you're going to have them be 1s also. And again, all of the variables that we're going to use are continuous, ranging from many different values, but they're all very correlated to the species. So this should be another very accurate model. So before making a model with multiple variables, we want to make sure that they are not too correlated with each other. By that I mean anything above 0.8 means that the variables are kind of too correlated to put in a model and they kind of explain each other. Like there's really no point in having them together in a model. So to do this, we're going to put our 4 variables into a data frame, and then we're going to make a correlation matrix and look at it. And here we have, you don't really want any of the numbers being bigger than 0.8. So it looks like sepal length and petal length are very correlated with 0.82. So we don't want the 2 of them in a model together. And petal width and petal length are also very correlated at 0.82 again. So we don't want those 2 in a model. So we're going to make a model that just doesn't include those variables together. So now we're going to make our model. Again, we're going to subset it to have some to test on later. So we make our training data set the same way we did previously. And this time we're going to make our model just with multiple variables instead of one single variable. So I also added an interaction inside just to spice things up a bit. Again, you put family as binomial, and our subsets the iris train. So then let's look at our summary. So it looks like a lot of these variables are insignificant according to R. This is just because all the variables are fairly correlated, so they explain each other, so we don't need them. We can make this model a lot simpler. So I'm going to drop a couple, and we're going to make another model. So this time I decided to just use sepal width and petal width, and decided not to put an interaction in. And we get much better p-values for these variables. So we're going to go ahead with this model. It's still multiple. It has 2 independent variables going on with species. So here we go. So now that we have our model, let's use our test data set to make predictions. So again, predicting is very similar. You just predict with your model. You have your iris2 without the training data set, and we are doing responses. So here's what the predicts looks like. I thought I'd show you this. So a lot of them are very close to 0 here, but it's not exactly 0. That's just how logistic regression does predictions. So again, we're going to need to find a cutoff point for what is going to be considered a versicolor and what is going to be considered virginica. We do this again by looking at the precision recall F measure. And this time, again, it's very close to 0.65 is when the drop-off starts. We're going to make sure that that is fine later, but it looks like it's going to be close to there. So now we're going to look at the predictions that were made. Again, we put them into one data frame, so we have the predictions and we have the truths. And I changed them from 0s and 1s to versicolor and virginica, respectively. And now we're going to plot them. So this model was way more accurate than the previous one. You see most of the values clustered by 0 or 1, which is great. We only had 2 things that went wrong. So on predicting virginica, we had 2 different values that were off and below the line. Remember, you want things to be either below the line on the left side or above the line on the right side. But this model was slightly better than our previous one with only 1 independent variable, which is great. So we can get the sensitivity and the specificity again. If we go down and make a confusion matrix, so I'm making anything less than 0.65 a 0 or 1 first off. Then I'm changing it from 0 and 1 to versicolor and virginica. And then we're making this confusion matrix, we're making versicolor the positive. So in this case, our sensitivity is 1 again, and our specificity is 0.982, which is slightly better than the simple model. And our accuracy is 0.96, so we did great. This model is almost perfect, and adding more variables probably won't make it that much better. So